Hello students, myself Dr.Rama Sarojinee, Assistant Professor Chemistry, Government Devi Girls PG College, Raipur. Today I am going to deliver a lecture on proximate analysis of coal. This is taken from M.Sc 4th Sem, 4th paper, Fuel Analysis. First of all, we must know why analysis is done. So analysis is done to determine the quality of any substance as well as the quantity of the element or substances present in that particular substance. We have to discuss about the analysis of coal here. Coal as a fuel. We know that the composition of coal varies according to coalification. What is coalification? Coalification, in simple words, we can say that formation of coal by the natural process. Or we can say it is the process of the chemical transformation from vegetation into coal, or it is the transformation of complex biological and molecular structure in the cells of plant in that form which we call as coal. So different types of analysis is done, and this is based on the use of consumers, and in general it is done in two ways. The first one is proximate analysis, we have to study today, and the second one is ultimate analysis. In general, the results of analysis are reported as first received basis, how we have received that. The second one, air dried basis, so dried in air only. The third one, on the basis of oven dried, that moisture free basis. And the fourth one, moisture as well as ash free. So now come to our topic, that is proximate analysis of coal. So as the name suggests, it is a proximate analysis, that is approx, not accurate. So it gives only about the detailed idea of moisture, volatile matter, ash and carbon. So it is an empirical or proximate, but still it is important also. It includes the quantitative determination of moisture, how much moisture is present. Number two, how much percentage of volatile matter is there, percentage of ash, and the fourth, percentage of carbon. So first of all, we must know about the significance of these contents present in coal. So first, moisture content. So it lowers the calorific value of coal. First of all, it lowers the calorific value of coal. So a particular amount of heat produced by burning or on combustion by a given weight of the substance is known as calorific value of that fuel. It is related to coal here. So it lowers the calorific value of fuel, that is coal, increases the cost of transportation because it is included in the weight of coal. So if more moisture is there, the weight or the mass of the coal would be more. and that's why the cost of transportation increases. Considerable amount of heat is lost. We know that during evaporation, heat is utilized in the form of latent heat. So in that process, heat is lost. So that ultimately fuel is wasting. So excessive moisture can quench the fire in the furnace. So the fire in the furnace get quenched if there is excessive moisture. Hence, lesser the moisture content, better is the quality of coal. Moreover, presence of 5 to 10% moisture is desirable. 5 to 10% moisture is desirable as it produces an uniform fuel bed and less of fly ash. Uniform fuel bed to stabilize and less of fly ash, because if there is more of fly ash, it uh, it will cause pollution. Now the second factor, second content, volatile matter. So volatile matter consists of complex mixture of gaseous and liquid products. And how they get produced? They get produced by the thermal decomposition of coal. When coal is heated, it gets decomposed and it produces a complex mixture of gases or liquid products. But moisture present in coal is not included here. So excluding moisture, the rest gaseous and liquid products which get produced during the thermal decomposition of coal. So it consists mainly of combustible gases such as hydrogen, carbon monoxide, methane and other hydrocarbons. If it is present in higher percentage, so it shows that fuel is burned, large proportion of the fuel is burnt as gas or vapor or may escape unburnt. And again, higher percentage of it gives long flame, that is again wasting, more smoke and again low calorific value. Calorific value again decreases. Coals having higher volatile matter do not cake well. So what is cake? So this is related to a process known as caking of coal. So caking coal is the coal which will form a solid residue on heating to very high temperature, around about 1100 degrees Celsius, in absence of oxygen or in little oxygen. Why in absence or in little? Because if more oxygen is present there, the carbon content of present in the coal will be converted into carbon monoxide or carbon dioxide. So it will react with oxygen present. So either there is absence of oxygen, or if present, then it should be in little quantity. And so if higher volatile matter is there, then we can't get a proper caking coal. So medium volatile coals, which have about 20 to 30% volatile matter, they form hard and strong coke on carbonization. So they give a proper coke. So it is good. So that much is required. Coals containing less than 14% volatile matter do not cake and hence not suitable for manufacturing coke. So higher is not required and lesser, that is less than 14%, is again not good. So medium range of volatile matter containing coals are good for manufacturing coke. Now the third content, ash. So beside moisture, volatile matters, coal contains inorganic mineral substances which get converted into ash during combustion, that is during burning. So it mainly consists of silica, alumina, iron oxide, and small quantities of lime, magnesia, that is depending on again qualification. Higher percentage of it means if higher percentage of mineral substances are present, then the calorific value of coal get decreased. Even if there is more ash, it may restrict the passage of air. The air supply get restricted, and hence rate of combustion also get decreased. Higher percentage of ash causing clinkering. If again there is more ash, or that is more percentage, higher percentage of mineral substances, inorganic mineral substances, it causes clinkering, that is formation of ash lumps, that is a small stone like a structure. So these all are the effect of ash content. So if now the fourth one, fixed carbon. Higher the percentage of fixed carbon, greater is the calorific value of coal and better is the quality of coal. So if the coal has higher percentage of carbon, then it is good in quality. Why? Because it has the greater calorific value. So these we discussed about the significance of the four contents. Now we have to find out, we have to determine that how much quantity of these are present in the given coal. So first, determination of moisture content. So what we have to do, we have to take a known weight of a coal in a silica crucible. Why silica crucible? Because it has a higher melting point. So we can heat up to a high temperature, and that is heated without lid in an electric furnace in an atmosphere of nitrogen, that is oxygen is not present. And why nitrogen? Because nitrogen is comparatively inert, and the temperature required is 105 to 110 degrees Celsius, and the time required is 1 hour. After heating for 1 hour, then it is taken out from the oven and cooled in a desiccator. Why in a desiccator? That is to absorb the moisture, because the desiccator contains anhydrous calcium chloride, which removes moisture from the substance. And after cooling, it is weighed. Definitely there is loss in weight because moisture is removed from there, and this loss in weight is reported as moisture content and is calculated as in the form of percent. Percent of moisture is equal to loss in weight divided by weight of coal taken. How much coal is taken previously, suppose like 1 gram or 2 gram, whatever, multiplied by 100. Now second, determination of volatile matter. The same sample, means that sample from which we have removed moisture, is taken in the same silica crucible, but this time it is covered and is heated in a muffle furnace at about 950 plus minus 20 degrees Celsius, and the time required is here 7 minutes to remove hydrocarbons and hydrogen. Then the crucible is cooled, first in air and then in a desiccator, and again it is weighed. Again there is loss in weight, and this loss in weight is reported as volatile matter, and in similar manner it is calculated as percentage of volatile matter is equal to loss of weight due to removal of volatile matter divided by weight of coal taken initially multiplied by 100. Now determination of ash content. So after removal of moisture, removal of volatile matter, the residue left after the removal of volatile matter is heated again in a muffle furnace at about 700 plus minus 50 degrees Celsius, and the time is required is half an hour without covering, because all the volatile matters as well as moisture is removed. Then the residue obtained is cooled after heating at 700 plus minus 50 degrees Celsius for half an hour. The residue is obtained and that residue is cooled and then weighed. And from the weight of residue, not any loss, just weight of the residue left, the ash content is calculated. So percentage of ash is equal to weight of the residue left divided by weight of coal taken multiplied by 100. So in the previous two we have considered loss in weight, but here weight of the residue left divided by weight of the coal initially taken multiplied by 100. Now the fourth and very important, determination of fixed carbon, because we know that greater the percentage of fixed carbon, better is the quality of coal, because greater is the calorific value of coal. So how percentage of fixed carbon is calculated? By subtracting the previous three contents from 100, because we have calculated in the form of percent. So percentage of fixed carbon is equal to 100 minus percentage of all these three, moisture plus volatile matter plus ash. Now in this lecture, I have included a numerical based on proximate analysis. Remember, numerical always helps to understand the principle, to understand the theory. So a numerical is taken here. A sample of coal was analyzed as follows. Exactly 2.000 gram coal was weighed into a silica crucible. After heating for 1 hour at 110 degrees Celsius, the residue weight is 1.975 gram. The crucible next was covered with a vented lid and strongly heated for 7 minutes at 950 plus minus 20 degrees Celsius. The residue weighed 1.328 gram. The crucible was then heated without cover until a constant weight was obtained. The last residue was found to weigh 0.205 gram. So calculate the percentage result of the above analysis. Solution is here. Mass of coal is given 2.000 gram. Mass of moisture in coal sample is equal to, we have to subtract here 2.000 minus 1.975. Now the loss is due to the removal of moisture, that's why we have to subtract. So the loss is 0.025 gram. Now similarly, mass of volatile matter is equal to loss in mass after second heating. So 1.975 minus 1.328, that is equal to 0.647 gram. And in the last it is given, last residue is 0.205 gram, that is the mass of ash. Now we have to put these values one by one to find out. So percentage of moisture, we know the formula, loss in weight, weight of coal taken multiplied by 100. So it becomes 0.025 divided by 2 multiplied by 100. It becomes 1.25%. Second, percentage of volatile matter, loss in weight due to removal of volatile matter divided by weight of coal taken multiplied by 100. So 0.647 divided by 2 into 100, 32.35%. Percentage of ash, weight of the residue left, weight of coal taken divided multiplied by 100. So 0.205 divided by 2, this is the weight of coal taken initially given in the question, multiplied by 100, it becomes 10.25%. So these 3 is calculated. Now for fixed carbon, we have to subtract these 3 from 100. So percentage of fixed carbon is equal to 100 minus percentage of moisture plus volatile matter plus ash is equal to 100 minus 1.25 plus 32.35 plus 10.25, and we get 56.15%. So this is the analysis done. Percentage of moisture 1.25, percentage of volatile matter 32.35, percentage of ash 10.25, and percentage of fixed carbon 56.15%. So this is all about proximate analysis. In the second lecture, we will study about the ultimate analysis, which is a comprehensive quantitative analysis, and it includes the quantitative analysis of various elements present in the coal sample, such as carbon, hydrogen, sulfur, oxygen, nitrogen, etc. So till then, thank you.